Good morning, everybody. This is Troy Conklin from uh, Broadcom these days, the Brocade Communications division of Broadcom. So today we're going to go through the new releases of the HPE SN6650B, HPE SN8600B, which is a 32 gig 64 port fiber channel blade, FOS 8.2, and HPNA 14.4. This is product readiness training that I absconded from internal. So there's a lot of information in here, and we're going to move along fairly quickly to keep up with everything.
A standard legal disclaimer, and a confidential disclosure agreement.
So I've kind of touched on this already, but the most important piece on this slide is the very last bullet. If you want more in-depth information, go to My Brocade, log in, and sign up for the web-based product update training. It's PUT227. And when you go and do that, you'll notice that a lot of the slides look very similar to the slides you're going to see going through here. Of course, when you take our training class, it's going to be in Brocade terminology, so it'll have all the Brocade names. It won't have the HP names, but we can talk through the translation of that here in a little while. But there is a lot more information in the PUT class. It's a web-based class. You take it at your own pace. But it is a lot more than the 2 hours we have today to get through. So there's whole sections and other information that I'm just not going to have time to touch on today because we got to get this done in 2 hours. So the learning objectives are to understand about, at least know what the new products are and features. So with the 32 gig 64 port blade, with the 32 gig 128 port fiber channel switch, the Fabric OS 8.2, and the Network Advisor 14.4. And do remember, if you have questions while I'm going along, you can throw them into the question and answer panel. And Matt and I also have my teammate Anna on the line to help answer those. And then I'll probably stop a few times along through here to see if there are any other questions. If you have a question you want to ask verbally, it always makes it more interesting for me. I guess probably use the hands up thing, and then I'll pause and we can see if we have any questions that we can answer as I'm going through the slides. So the first thing I'm going to talk about is the SN8600B. It's a new port blade for the chassis for the 8600. So it's a 32 gig 64 ports. It has 8. That ended up looking a little funny, but it's a 64 port blade using QSFPs to give you that port count. So it has 16 QSFPs on the blade.
Yeah, Troy, the 8 QSFPs is indicating that when we ship it, we're going to have 8 32 gig QSFPs populated in the blade. So there will be 8 open QSFP ports.
Gotcha. Okay, thank you.
Yep.
And that's why we have Matt on the line. Keep me honest here. Okay, so before I jump into the blade, I'm going to go through the Condor 4 Plus ASIC. Now, I know if you've been through this training before with me and Matt, you've heard about the Condor 4 ASIC. So the Condor 4 Plus ASIC is a slight improvement to the Condor 4 ASIC, and we'll go through what exactly that means. But it is just like the Condor 4 ASIC, it's a 64-port Gen 6 ASIC. The things that we've added over the Condor 4 ASIC are I/O statistics to support Fabric Vision for NVMe over FC, because as we all know, NVMe is a big talking point right now, and people are moving in that direction. So we decided to spin our ASIC to support the statistics of it for NVMe over Fiber Channel. The ASIC also supports flex mode, so it allows us, by default the ports are all in Fiber Channel mode, but it allows us to put ports into FCOE mode, so we can connect to hosts, FCOE hosts. And you can do up to 32 ports per ASIC in flex mode, 32 of the 64, and it supports Ethernet speeds 10, 25, and 40 gig E via the QSFPs. And then also performance Ethernet encapsulation decap for Fiber Channel frames for FCOE, because we're translating from FCOE into Fiber Channel and vice versa. But it is feature compatible with Condor 4 ASIC, and it supports all the same fiber channel features of the Condor 4 ASIC. We just added some of these NVMe pieces to it and the flex mode. Okay, so moving on to the 32 gig 64 port blade. So there's a little picture of it over on the right. I think we have a little closer picture later. So Brocade calls this the FC32-64 port blade, and in HP nomenclature, it goes in the SN8600 chassis, but it's a 32 gig 64-/32, and it comes, as Matt said, it comes with 8 QSFPs populated in the blade up front. It is a 64 port blade, Gen 6. It's got a high port count, and the only way to get to that kind of port count in this size of blade is to use QSFPs. You just really can't get that many SFPs in there. And if you've been around a while, we tried this before with mini SFPs, which worked pretty well, but it wasn't as easy to deal with because it was a different cable end, so it had its own set of challenges. But this blade does offer support for multiple connectivity offers options. So it runs fiber channel by default, but you can also put it into FCOE mode, and you can also run NVMe over FC on this blade as well. But it does because with the FCOE portion, it does support connectivity to Cisco UCS blade servers. So if someone for some reason has a Cisco UCS blade server, we can bridge them in to get to fiber channel storage. So you could have your fiber channel 3PAR connected to the fabric, and you could bridge the Cisco UCS box into the Broke B series fabric to get to your storage. What else? So enhanced manageability for NVMe. So I touched on this a little bit. So the Condor 4 Plus gives us extra insight into what the NVMe packets are doing, just like we do with the fiber channel with the SCSI frames that are going over fiber channel these days. Some more details here. This blade is supported with FOS 8.2.0 and later. So if you have a chassis with 8.1 and you put this blade in, it's not going to bring it up because it doesn't know what it is. And it's also supported in BNA 14.4.0 and later. So if you have BNA 14.3, it's not going to recognize the blade either. The blade is supported in both the 4-slot and 8-slot versions of the SN8600B. There are 2 64-port Condor 4 Plus ASICs per blade. So if you remember previously, we said that you can do 32 ports per ASIC for FCOE, and because you only are exposing 32 ports per ASIC on the blade, you can all 48 ports can be put into FCOE mode if you wanted to. It does have an oversubscription ratio of 1.33 to 1, so it's better than the Gen 5 blade, which was 2 to 1. So it's less oversubscribed, and of course, if you use local switching, you can drive that right down to 1 to 1. It supports 8-port trunks, so pairs of QSFPs can be trunked together to give you an 8-port trunk, just like normal. And it's got the other standard, total power monitor and LED indicators, things you would expect. Now, being a 64-port blade, that means there's, of course, 16 QSFP ports on here, which if you loaded up one of your 8600B chassis with 8 of these, you can get up to 512 32 gig fiber channel ports, which is a very dense platform in the U count. You can also put them all into FCOE mode and get 10, 25, or 40 gig FCOE servers on all of your 16 QSFP ports, as I mentioned. It is fiber channel. These are fiber channel compliant QSFP ports, and the optics will support 32, 16, 8, and 4 gig speeds, depending on which QSFP optic you put in there. Of course, because of the speeds, we don't support OM1 or OM2 support for cabling. You do need the newer OM3 or OM4 or anything that's newer like that to get your distances. Otherwise, the distances are just too short. Hopefully, you haven't had to experience that. The 32 gig QSFP does support optical and electrical loopback for ClearLink diagnostics. So that was something that we've worked with the SFP vendors to get that little piece of technology added in there. So let's see down here at the fiber channel optics, they're called Z QSFP pluses, is kind of the technical name for them. But you can either put in the 16 gig or the 32 gig QSFPs here. And then, of course, we've talked about the Ethernet speeds. And then, for the Ethernet optics, when we say 40 gig, it can support 4 by 10 gig to get to 48 gig, but we also support 1 by 40 gig, where all four, if you think of them as four cables, it goes into 4 lanes, so it's one 40 gig pipe as opposed to 4 lanes of 4 channels of 10 gig. To get to 100 gig, it's 4 channels of 25. So here's a little bit a drawing of the blade, so you can see it a little bit easier. So pretty standard compared to all the other blades. Nothing really shocking here. You got your power and status LEDs, and that's the top of the blade, and when it's in the chassis, and then the bottom of the blade, just like normal, it starts with port 0 and works its way up, just like all the other blades. So nothing surprising there. It looks like I've got a question, Ranjith. If we can take him off mute and go ahead and see what the question is while we go.
Should I open the line for the verbal question?
Oh, we put in, said 4 by 25 equals 1 by 100. It does 4 channels. I'm not sure what the correct Ethernet terminology is here, honestly. It's 4 of 25, it's just like 4 by 10 is mathematically 40, but there's also 1 by 40. There are 2 different flavors of 40 gig. We don't do the 1 by 100 yet. Currently it's doing 4 by 25. So you're kind of getting to the limit of my Ethernet knowledge, honestly. I'm a fiber channel geek myself. Okay, so for the blade, the mapping, so the ASICs are top and bottom, so top half, bottom half is how it maps through, and there is no connectivity between the ASICs right here. So if you have a device connected to the top half, it can't do local switching and talk to a device on the bottom half. It can talk within the ASIC, so the top 8 QSFPs can talk directly to themselves without hitting the backplane, and the bottom 8 can talk to each other without hitting the backplane. But if they have to go from top half to bottom half, it does bounce through, and that's pretty standard from all of our blades that we've been doing for quite a while. So that shouldn't be too surprising. Some software licensing options. So this blade has the standard port licensing options supported in the chassis. There are no new additional licensing requirements. There's no license for FCOE. There's no license for NVMe. If you want to use NVMe, you just need an NVMe host and storage. And if you want to use FCOE, you just change the port type to FCOE and off you go. There's nothing else to buy or nothing you have to do like that. There is no FICON support here from IBM, and that's of course an IBM question. And I'm just passing along the information. They decide if and when. They are going to do some Z-Linux, but that's FCP. It's not FICON. They're not going to do FICON channel support on this blade as far as I know at this point. They can always change their mind, but that's the plan as far as I know it. The optics for this blade, you can put in a 16 gig QSFP, and that generally it's a 16.84 gig. And then the 32 gig QSFP is a little different than what we've done in the past. It's only a bi-speed, so it's got 32 gig and 16 gig speed supported. And of course they can both do breakout. And then there is also a 32 gig 2 kilometer CWDM optics option that you could use if you need that kind of distances. And then for FCOE connectivity, there's the 100 gig, which is 4 by 25, which can also do breakouts. So you can get 4 lanes of 24 cables of 25 gig each if you want. And then 40 gig. And then a 40 gig, you've probably heard of this, a 40 gig direct connectivity for short reach BiDi. So it's a little bit different kind of a beast, but it's something that Cisco's been pushing. So that's why we support it as well for our connection into the UCS. Some more things here. So the ports all support both fiber channel and Ethernet protocols, as we've kind of talked about. For Ethernet, it supports cable breakout and non-breakout mode. So if it's a 1 by 40 gig connection, then you can't break it out. It's one big pipe of 40 gig. If it's 4 by 10, then you can break it out. So it depends which mode you've got it in, whether you can break it out or not. Of course, we support FCOE, as I've mentioned. Some more details on the Condor 4 Plus. We've got 40 VCs in there, just like the FC32-48. The Condor 4 Plus does support 48 VCs, but we're only using 40, so it matches the previous blade that we've already supported in there. A little bit of information about the flow generator, and for some additional Condor 4 Plus features down here at the bottom. include, of course, Ethernet support, jumbo frame, buffer allocation, and NVMe I/O stats, which we've kind of all talked about. Some power requirements. If you have these in your chassis, it does need 3 power supplies in the 8-slot chassis and 2 power supplies in the 4-slot to make sure you have enough power, because it's more ports and more ASICs, and so it's a little bit more hungry than the lower port count blades, of course. For HA support, it will, your CPs both have to be at 8.2 for you to be in HA mode, because 8.2 is the only thing that understands, 8.2 and newer is the only thing that understands these blades. So if your standby CP has 8.1 or earlier, you won't get HA sync on the blades, even though you would have without that blade in there, simply because if it failed over to 8.1, your blade's going to go down because it doesn't know what it is. So that's pretty standard stuff from, historically speaking, of how the chassis have pretty much always worked. And if you have the blade inserted into the chassis, the switch will detect that and not let you do a firmware download to something pre-8.2, because it knows, we do some pre-flight checks to say, oh, that code doesn't know what this blade is, so we're not going to let you download, because you're going to end up knocking that blade offline, and that's probably not what you want. And if that is what you want, pull the blade out and knock it offline by hand, and then I'll let you do the download. One other thing here, for in-flight encryption and compression, that is not supported on this blade at this point, so I'm not sure if that's going to end up showing up later, but that's the current state of affairs. As we've kind of touched on this a bit already, the ASIC supports NVMe over fiber channel and Fabric Vision and performance latency monitoring for NVMe. That's some of the things we added in to create the Condor 4 Plus. And of course, it supports flex mode. So this is all things we've kind of already touched on. So that's the summary of the 64-port blade. Do we have any other questions on that blade right now? Otherwise, I'm going to move along to the SN6650B switch.
Yeah, Troy, I just wanted to note on the SCOE support, we have tested it with HPE CNAs, and we do support them as well as the Cisco UCS.
Excellent. Thank you for pointing that out. So Ravi kicked in a question to the chat room. Firmware downgrade is not possible. It's not possible if you have the blade in a chassis. It's because the only code that recognizes it is 8.2. So if you're running 8.2 on both CPs in the chassis and you have the blade, if you try to downgrade to 8.1, it's going to block you because the blade's in the chassis. If you pull the blade out of the chassis, now it will allow you to do the downgrade at that point, but the blade isn't going to be recognized. So if you try to put it back in, it's not going to power it up, because it doesn't, that code level doesn't understand that blade. So the minimum for that blade is 8.2. Moving on to the SN6650B. This is a 32 gig, 128 port fiber channel switch. So you can see a picture of it down there on the bottom right. It looks, within Brocade, we call this the G630 switch. So if I slip up and say that's what it's the same thing. The 6650B is the Brocade G630. If we've seen the G620 switch, that picture looks very much like I just took 2 of those things and kind of pasted them together, and it's from the outside, it pretty much is. It's a little different on the inside, of course, because you need more ASICs in there to cross-connect everything. But it's basically 2x of a G620, which is I'm blanking on the HP name for the G620. But so this is a 128-port enterprise switch. So this is the big switch that we come out with. We always come out with 3 different sizes of switches: the small, medium, and large. And this is the large, kind of enterprise, almost enterprise class. Doesn't have dual CPs like the chassis do, like the directors, but it is a very large, high density port count switch. This is going to coexist with the SN6500B, the Gen 5 version of this switch. We're not going to end of life that thing very quickly. We're going to let them both live for a while, and as the 6500 ramps down and the 6650 ramps up, then Brocade and HP will make the choice of when to end of life and end of sale the 6500. So this switch does provide 96 32 gig SFPs. So most of that surface area are SFPs, but it also does have 8 QSFPs over here on the right. So 4 on the top and 4 on the bottom to get up to the total port count of 128 ports in the switch. It does have a little over 4 terabits of switching bandwidth. It has the pods for the pay-as-you-grow model, just like we always have. So you can pod up. The SFPs are a separate pod from the QSFPs. So if somebody if you buy this as a base, and we'll touch on this in a little bit, you get half the SFPs enabled, and then you have a couple pods to bring it up to full SFP count, and then there's a separate pod license to enable the QSFPs. So the customer doesn't have to buy the QSFPs if they don't actually want them right now. So they can wait and spend the money on that later on when it's time and when they need it. They don't have to buy that up front. And of course, this has a hot swappable power supplies and fans, and we'll touch on that. And the minimum supported, as I mentioned previously, is 8.2 and BNA 14.4. Previous to that, it's not going to recognize what it is because it's just too new. So a little bit more detail on the layout of the switch. So I'm not going to touch on all of this, but the status LEDs are up on the top left on the USB port, the serial port and Ethernet port. All the QSFP ports are in these blocks 4 and 13, and then over on the right edges are all the QSFPs. Pretty straightforward and standard Brocade Broadcom design that we've been doing for a while. For the port numbering, it's very similar to what we've been doing as well. So starting up in the top left is 0 through 7. So it's 0, 1, 2, 3, 4, 5, 6, 7, and then it goes to 8, 9, 10, 11. So just like we've been numbering the switches for quite a while now. That's how it slides along. And then once you get over here to port 95, then we go into the QSFP port. So it's kind of back up into the top left of the QSFP. And it's 96, 97, 98, 99, and then 100, 101, 102, 103, and then it just continues counting on in the same method. On the back of the 6650, there are 3 fans and 2 power supplies. So it's all redundant, and they're all through, so you can swap them out if something was to fail. The power supplies are 1500 watt, and the power supplies also have integrated fans as well, just to keep the power supplies cool. The power supplies do come in 2 variants, so back to front and front to back. So if most people do the back to front, so the air exhausts out the port side. But there are, every once in a while, you run into somebody that wants to put this into a NOC or something where the airflow is backwards from what we normally see in a data center. So then you can get the other version of it so that it matches the airflow and it's not sucking in the hot air. Let's see. This is AC power only. There is not currently a DC power offering. I know we've done that a few times. We've had a few segments that have wanted DC power, so there are a few options of that in other products, but not in this one at this point. The fan through has 3 different fan speeds that it can run at depending on what the temperatures are doing, and it'll ramp up the fans. It's kind of similar to how your Synergy and C-Class chassis do it as well. What's else important here? Of course, we have both airflow directions, so the fans have to have both flavors of front to back and back to front as well. If for some reason you mix the fan throughs that are blowing in different directions, please don't do that because the switch, it's not really very good for the whole unit. The switch will not be shut down, but the fan running in the direction not preferred by the user will be faulted, and the switch will keep an eye for thermal instability, but you don't want to leave it like that. That's not very good for your systems. And if one of your fans running in the correct direction fails, you've really only got 1 fan left, so it's not a state you want to leave this thing in. So the port mapping to ASICs, which is important for direct local switching, and then it has to do with trunking boundaries as well, but it's also kind of important for some of you more detailed folks to know about, is there are 5 ASICs in the chassis, in this switch, and so the way they map to the front user ports there's the green ASIC here, a blue ASIC, and a whatever lavender color that is. And then the other two ASICs have the QSFP ports. So there's an ASIC for the top 4 QSFP ports, and there's another ASIC that are mapped into the bottom 4 QSFP ports. We'll talk more about the repercussions of this, and if you want more details on what and why, we won't have time to get into that today. But as always, I'm happy to have conversation about this stuff, and we can talk to more details if you think you need it. And I know there's probably 3 or 4 of you that might want that, but most of you shouldn't have to care. Somebody had asked if is Access Gateway supported on the 6650 switch, and I believe the answer to that is no. It's such a large switch that we wouldn't normally support Access Gateway on the big switches, and we never have, not on the 6600 either. We'll get the answers in the system as well to make sure it's tracked. And then is local switching much faster than non-local switching? So with local switching, it means what we mean by that is it. So for instance, in this slide, if you've got local switching, it's not as big a deal in the switches as it is in the directors. But if you have somebody that wants to, say you have a server on port 0 and a storage on port 1, and those two want to talk, the frames hit the ASIC and bounce right back out. That doesn't go anywhere else. If we didn't support local switching, then it would have to hit port 0 and then go hit some backplane or someplace else and then get shot back out to port 1, even though the ports are physically right next to each other. So that's basically what local switching is. So local switching is faster simply because you're not hitting as many ASICs. And so every ASIC is going to introduce a certain amount of latency. That's just the law of physics. And the fewer you hit, the faster things go. So that's kind of what that is. And then, of course, as we talked about with the 64-port blade, because it's 1.33 oversubscribed to the backplane, if you didn't do any local switching, it would always be 1.33 oversubscribed, and you couldn't get full speed out of that thing if you did a little bit of thought to where you plug things in. But because we can do local switching, depending on how you hook things up, that thing will run full line rate. It just depends on where your devices are. For the trunk boundaries, I put little boxes around it so you can see ports 0 through 7 is a trunk boundary, so that you can build that into a single 8-port trunk if you want. And then when you get to the QSFPs, it's top left and then down a step. Those 2 QSFP, which are 8 ports, is a trunk boundary. So you could build an 8-port trunk out of those 2 QSFPs, and then that's a trunk boundary, and another boundary, and another boundary. So that's how the trunking lines up. And it is color-coded on the front of the switch, just like we always have. So it should be fairly obvious when if you're physically looking at the front of the switch, where the trunk boundaries are with the Mylar that's on there. So firmware and feature support, it does require 820 or later, like we've been talking about. It does support hot code load, all the standard port types, FE, EX, SIM port, and D port. You can use virtual fabrics and carve this guy up into 4 logical switches. FOS diagnostics. It does support in-flight encryption and compression with FOS 820A, which is what you launched with. So the short answer is it does support in-flight encryption and compression. Of course, FICON and AG are not going to be supported on this. FICON because that's what IBM chose, and as Matt already answered, AG support isn't supported, and we never support it on the bigger switches. That's only ever on the smaller guys. You can do ISL trunking. 2 QSFP ports can be trunked together, as we talked about. And you can do 10 gig fiber channel on here with the 10 gig fiber channel SFPs if somebody has a 10 gig DWDM metro that they need to connect into. So we can do that as well, just like we have been in the past. For the pod licensing, I touched on this already a little bit. So if you buy a 6650 with no pods, it comes with 48 SFP ports active. And then you can add 2 more 24-port pods one at a time if you want to get all 96 SFP ports active. And then we have another license, which you should have already heard of with our previous mid-range switch, a QFlex port, which will enable the QSFP ports. And so if you buy that license, you get, it says 132 port. QSFP pods. So that'd be 8. Yeah, so you get all 8. You either have all the QSFPs on or all of them off with the QFlex pod. We decided not to split that up because if you're going to use them, you're probably going to want to use them all because those are really good for connecting from switch to switch as an ISL. You can also use them for devices. We're not limiting you to that. We'll talk about that in a little bit too.
Yeah.
So
before you move on, Troy, I had a couple comments on other licensing that we don't have listed here. So we'll be offering the switch as a base unit and as one with some integrated optics in it. Along with that, we'll have the pod license for the SFP ports. We'll have the QFlex pod for the QSFP ports. We'll have the PowerPack Plus offering and the integrated routing license as well.
So a quick example of the pod license, very similar to what you've seen already. So this should all look fairly similar. You can use the license port reserve and to pre-reserve ports if you know that the customer has a certain layout that they want to use when they're hooking things up. But that's all. None of that's new. I'm going to go through a little bit of the optics support. Just kind of touching on what is available. So in this chart, we've got the optics, just kind of what the optics is, whether it's supported in 8.2.0, which is what we're launching with. What is the plan to be supported in 8.2.1, which is not launched yet, but that's kind of the next decent sized release from us. And then for whatever's beyond 8.2.1, it could be 8.3 or 9.0 or whatever they decide to number it. I don't know what they're going to do. So with the 8.2.0 launch, we support the 32 gig shortwave and long wave optics. It does not currently support 32 gig extended long wave, and we might be able to get that into 8.2.1, but it will definitely be included beyond 8.2.1 with that timing. The 32 gig QSFP, we do support that. With this, there's a flavor of it that supports it, but it doesn't support breakout. And then there's another flavor of the 32 gig QSFP that does support breakout. So there's a couple different flavors of that thing. And then there's the 2 kilometer for 32 gig QSFP, which that one doesn't support breakout because that's just for long distance reach to get to other places. The 16 gig QSFP or the 16 gig SFP is supported, of course, because we always support the previous generation of speeds to get that, the lowest speed and be able to support that in the switch. And then the 16 gig QSFP with breakout. And of course that one supports 16, 8, and 4. So that's how you can get down to the 4 gig speeds if you need it. And then of course the 10 gig. QSFP best practices. Now this gets a little bit interesting, and this is where I suspect there's going to be a small handful of you that are going to want to chat about this later. I'm not going to be able to, unfortunately, I just don't have time to get into this in a lot of detail. But if you remember the picture of how the ports are the ASICs that the ports each use, that plays directly into this part that we're going to go into now. And why some of these rules are, and I'm not going to get into too much of the why here, but if you want to talk about it, I'm happy to do that. Just it's going to need to be offline. If you're using the QSFPs for ISL connections to other ports, other switches, so in this case, so essentially this is the 6650B. So those are the 8 QSFP ports in the 6650. And if you want to connect to switch 3, what they're saying is if you're going to use QSFP ports, the best practice is to use, if you're going to use, say, QSFP that's ports 104 to 107 to switch 3, you're going to want to do 2 of them, 2 connections. Of course, you always want 2 connections for redundancy. And the second connection needs to be to the bottom half. So 1 to the top half, 1 to the bottom half. And this has to do with the ASIC layout and other things that I'm not going to get into, but this is the best practice. So you notice these are all 1 to the top, 1 to the bottom if you're going to use them for ISL connections. And then it has the groups and the port numbers and things here, but it's basically 1 to the top half, 1 to the bottom half.
Now here we're showing if you needed more bandwidth between your 2 switches, you can use trunking on your QSFPs. And so we're showing an 8-port trunk going to the top half and an 8-port trunk going to the bottom half. And if you remember the trunking boundaries that we talked about earlier, it's, of the 4 QSFPs, it's the left 2 and the right 2 are the 2 separate trunk groups, and same on the bottom. So we've got 2 different 8-port trunks that could go between 2 switches.
In this case, if you're going to use the QSFPs and you're connecting to switches that don't have QSFP ports, they only have SFP ports, you're going to have to break out the links, which is perfectly fine. We don't really care either way, but it's still the same rule. So if you're going to use a QSFP to switch 2, it's going to break out into four physical cables at the other end, but then you need another connection of 4 physical cables to a QSFP on the bottom half. So these are all the best practices. So it's the same rule, it just happens to be breaking out at one end.
And if you want to do trunking with breakout cables, it's the same thing as before that we saw a couple slides ago. You just use the left 2 most or the right 2 most in the QSFP group, and you still need connections to the top and the bottom. So it's all the same rules, it just happen to be breaking out this time.
Let's see. So this is if you're using your QSFP ports. In this case, you want to hook to devices. So in this case, if it's just a standalone switch and you're not going to ISL it to other things, the best practice is to use the SFP ports for your host ports. Generally, you end up with a lot more hosts than storage anyway. That's how the subscription ratios usually work. Not always, of course, but usually. The best practice is to use the SFP ports for hosts and then use the QSFP ports and break them out to your storage arrays. In this case, if I'm doing both E ports and F ports at the same time and I need to use my QSFPs for that, your E ports still have the same rule. I still need to connect to the top half, bottom half for those. And then if you need hosts or storage, you can connect them, but you do want to spread those around as well. You don't want to just put them all on the same. You don't want them all on the top or all on the bottom. You got to spread those out, spread that load out a little bit. And then if you're going to connect to AMP, the recommendation is to use the SFP ports for those connections and not to use the QSFP ports for those connections. It would work, but it's the recommendation for more detailed reasons is to use the SFP ports. I think that's it for the QSFP connections. So let's see if they have any questions in here. So I see breakout is supported on the QSFPs. There is an older 32 gig QSFP that doesn't support breakout, but my guess is you shouldn't see that very often. Most of the time, you're going to see the breakout QSFPs 16 and 32 gig to be able to do that.
That QSFP actually isn't supported in the switch, so it should come up as module invalid.
Okay, good.
All of the QSFPs that are supported in the switch do support the breakout.
Okay, perfect. That makes it much easier. Okay, any other questions on this before I move on? If you have the more detailed questions, it's going to have to wait as to the whys and the more flow frames and things like that. And I'm happy to talk about that, but just not at this point in time of today. So moving on into the FOS 8.2 enhancements that you'll see in this just the generic FOS release. It's kind of above and beyond the hardware that we've already talked about. So in the D-port support section, so we do support D-port on the 6650 and in the 32 gig, the 64 port blade. D-port is not supported on the FCOE ports, and that I believe that has to do with the optics and being able to bounce it off the other end. There are some restrictions on the electrical and optical loopback tests. The same configuration has to be on all 4 ports of the QSFP. You can't do different things on different ports because it is still a block of ports. So trying to mix stuff up is not going to work. It's not going to let you do that stuff. And then D-port is supported with HPAs on the 32 gig and 16 gig links. So you can do that with the HPAs, and pretty much both QLogic and Emulex do support D-port between the switch and their HPA ports. Hopefully you haven't had to see this specific feature before, but there is sometimes you can have an issue where a blade will actually get faulted and knocked out of the usage. And so a new feature that we've added is blade fault auto recovery. So what this will do is, and the important thing in here is this right here, only one auto recovery attempt is given. So if the blade faults, we'll basically put the blade to sleep for about 60 seconds. We'll bring it back up, see if it's okay. If it faults again, it's down. It's going to be off just like it would in FOS 8.1. But we will give it one shot just in case there was something transient that was going on that when you unfault the blade, everything is working fine. So it must have been some sort of a weird transient thing, but at least the system will fully recover and not have to wait for the admin to wake up the next morning and come in and take a look at it and then bring it online and say, well, it's working fine now. I don't know why it did that last night. So this is hopefully something none of you have ever seen, but this is just to make our life a little bit easier and make the customer a little bit happier. So if the auto recovery fails, it will be faulted again and then it will stay down, and then the admin is going to have to do a slot power off, slot power on to bring it back. There are some RAS logs that talk about this. So you will see like the EM 1100 is the first fault, and then EM 1101 is if the auto recovery fails and now it's down. You'll see that, so you can tell the difference in the logs of what was happening. And then firmware upgrade downgrade, it is supported when blade auto recovery is enabled. So if you're going to downgrade from 8.2 to 8.1, which doesn't support auto recovery, if the feature's turned on, it's not going to block your downgrade because it's a feature that kicks in. It's not something that's running all the time. So it's okay to downgrade, and then of course you lose auto recovery, but it's not going to block you from doing that. And then if you decide that the customer does want to enable this feature, you got to do the configure chassis command, and it's system enable blade auto recovery, and you can turn that on. And it is, in this case, this example is showing it on or it's already on, and they're just turning it off. And then if you want to look and see what the status is, if you use the config show, you can grep for blade auto recovery and see the state of the bit. So in this case, I believe it's showing it as disabled, and it is disabled by default. So, and I should say disabled by default in the Brocade FOS. This is something that Matt and I and others need to talk about, just decide what we want to do from an HPE point of view. Do you want this on by default or do you want this off by default? But just want to make sure you know about the feature. Okay, so some fixed speed support for the Gen 6 core blades. This is a little bit funny, but it's actually kind of important, and I think we actually just bumped into this in the field just about 2 weeks ago. So for the 8600 directors, both the 8-slot and the 4-slot, of course, it has the 2 core blades that have the ICL ports on them. And ICL ports only support fixed speeds of 32 gig or 16 gig speeds. Those are the only 2 speeds they support, and it can only run one or the other. And unfortunately, we can argue whether this is a defect or not, but you can put the ports into auto negotiate mode, but what that really means is fixed 32 gig is what that actually means. I've argued with engineering about this, but I haven't won yet. So if it's in AN mode, it's really what that really means is 32 gig fixed. So if you try to connect your 8600B to your previous generation chassis with ICL ports that only run 16 gig, the link's not going to come up because the 8600B is going to be running at 32 gig and the older chassis is going to be running at 16 gig, and of course nothing can happen. So if you're going to do that, you need to lock the speed to 16 gig, and then the link should come up happily. Oh, but it is a good point here. If it's configured as AN, and if the port is configured as AN and you insert a 16 gig QSFP, the port's going to get faulted because the port speed is not matching what the SFP is. So it's in conflict. So you're going to have to manually set the speed to 16 gig, and then the QSFP will come online. You'll be able to use it. Okay, so if you're looking at the port in switch show, so let's say the port is in auto negotiate mode, it's going to say locked 32 gig speed, just like you would normally expect to see if it was locked in 32 gig. So it's not going to show you it as AN, it's just going to say 32 gig. So it's going to display it I guess, properly. I wish that AN didn't even exist would be my preference, but it does. But that's how it's going to display in the switch show. And then here's a table that kind of explains what happens with the QSFP type and what the port speed is, and it's kind of stuff we've already talked about. I'll let you look through that. If you have questions, let me know. I'm not going to step through all of those. Now some unsupported blades in a Gen 5 chassis. So this is jumping back. We've been talking about the Gen 6 chassis quite a bit. Now we're talking about the Gen 5 chassis running 8.2. So if you have a Gen 5 chassis and you have the FC8 48E, the FC8 32E, or the FC8 64 blades in the chassis, those aren't supported in 8.2. So if you're running 8.2 and you put those blades into the chassis, they're gonna get faulted and you're not gonna be able to use them. So the 8 gig blades won't be supported in 8.2 anymore. And then of course it's also, if you're running 8.1 and you try to update to 8.2 with those blades in the chassis, it's going to block your update and actually tell you that the FC832 blade is not supported by the target firmware. So you either don't upgrade or pull the blade out and then you can upgrade, but the blade's not going to work at 8.2. So it does protect you to make sure that the customers don't get themselves into funny states. Okay, so now I'm going to move into changing gears a lot. I'm going to move into flex port support with the Condor 4 ASIC, which is, of course, taking a port and putting it into FCOE mode from the normal fiber channel mode. So the CLI command to do this is port CFG flex port, and that will let you configure the mode of the port. It is a persistent configuration, so if you reboot or whatever, it stays in the mode you set, and it's included in the config upload download, so it's persistent like you would expect. It's not something that goes away. Let's see. We talked about the QSFPs already, and there are breakout and non-breakout Ethernet QSFPs. 10, 25, and 40 gig speeds are supported. We do support lossless Ethernet PFC or PFC, priority flow control. And then we do hardware-based and decap of the FCOE into fiber channel in the blade. You can do these deployments with and without lag. You can connect this to CNAs, UCS, a FIP snooping bridge, and then as Matt mentioned, with the HPE CNAs have been tested, so those are also supported. And there is, as I said previously, there is no license required for this. You just need the appropriate pod license to turn the port on. And once you do that, you're good to go. We don't charge you any more for this feature. You can just enable it if you need it. So we talked about the port CFG flex port. That it's going to configure a group of ports as either fiber channel or Ethernet. There's also port CFG breakout. So that is how this only applies to Ethernet. This is an Ethernet only command because fiber channel doesn't do this. But that's how you take a 4x10 gig or a 4x25 gig and differentiate between the 1x40 gig. So that's really the 1x40 or the 4x10. That's how you put it into 1x40 operation. And then at that point, you can't break it out anymore because it's a single connection of 40 gig as opposed to 4 lanes of 10s. And of course, FlexPort is only supported on this blade. So in the 8600B director with the blade we've been talking about, and you can take as many of the QSFPs can be put into Ethernet mode as you want. You can put all 16 QSFPs into fiber channel mode if you'd like. It's just fine. And also here at the bottom, there's no limit to the number of these blades you put in a chassis. So you could have a chassis with 8 blades, 8 of these 64 port blades in there to have 512 ports in the chassis, and you could have them. You probably wouldn't have them all in Ethernet mode because you're still going to want connection to some storage. But you could put as many of those things in the chassis as you want. So here's an example of the port config flex port. And also, here, this is a good point. It converts all the ports in the group at the same time. So you can't take a QSFP and say, oh, I want 1 port in Ethernet mode and I want the other 3 ports in fiber channel mode. It's not going to let you do that. It's a per QSFP operation. So it'll turn all 4 are either fiber channel or all 4 are in FCOE mode. Okay, so in this case, we've got the port. In this case, we're looking at a switch show. You can see it's in 40 gig mode. It's 40 gig QSFP in there. It's in Ethernet mode. And it says disabled persistent QSFP secondary port. So in this case, what we did was we did a port disable on the 4 ports, and we used the port. Hopefully, you've seen this before. In this case, we did a port range. So we said slot 4 ports 44 to 47. So all 4 ports. You don't have to do the command 4 times. You can just do one command and list all the ports like that. And then we said port CFG flex port. I want to put the protocol into Ethernet mode, and all I have to do is hit the top one of the ports in there, and then it will convert all 4 in that QSFP into Ethernet mode. And then here's switch show, and it's like, okay, it shows all 4 ports, and it says this one is disabled and this one is a secondary port, and only the first port in the quad can be enabled and used. So in this case, it looks like it's gonna be a 40 gig port, and then you really only, the other 3 are just kind of in the background, and really the port 44 is your kind of main port for this in this case. Okay, so when you're using an FCOE port and breakout mode, so we've talked about this a little bit. You can either use all 4 lanes, the single port with 4 lanes, or 4 individual ports. So you can have breakout mode with 4 ports at 10 gig or 4 ports at 25, and then you can have non-breakout, which is 1 port at 40. It just really kind of depends what you've got on the other end and what mode you want, and then we'll allow you to do whichever of those you want to do. By default, Ethernet QSFPs are set to non-breakout mode, so they've made a choice as to what the default is. So it defaults to 1 by 40 gig. So if you need 4 by 10, then you just have to change the breakout mode, and then it's 4 by 10. So some flex port restrictions. Ethernet flex ports can only be used for FCOE. So if you try to hook up just regular old Ethernet and use it for TCP/IP, that's not supported. This is only for FCOE. Forward error correction is not configurable on flex ports configured for Ethernet. It's enabled when the speed is set to 25 and disabled for all the other Ethernet speeds. That's just how it works. The Brocade VDX, which is no longer the Brocade VDX, had a feature called Trill, and that is not supported in this blade. There's no FCIP support on flex ports. You can't use that Ethernet to tunnel fiber channel over. It's for FCOE, not fiber channel over IP. There's no speed negotiation. You have to hard set the speed to whatever you want. And currently, there's no long distance support for it. Its support is less than 2 kilometers, because that's what the regular shortwave QSFPs can do. So flex port upgrade and downgrade considerations. So as we talked about before, if the blade is in a chassis, you can't do the downgrade because it does the pre-flight checks and says, 8.1 doesn't understand what that blade is, so it won't let you do the downgrade. And if you have, if one of your CPs is running a pre-8.2, you're not going to get HA sync, which we kind of talked about already before. But if you're upgrading from 8.2 to something that's newer than 8.2, so let's say you're upgrading to 8.2.1, so then you do get non-disruptive HA upgrade downgrade, as long as both versions do support the blade, and it doesn't really matter if the flex ports are enabled or not, because the blade is supported. It'll let you do the HA upgrade downgrade, just like you would expect. Okay, so that's kind of it for that level of it. So now I'm going to talk about the FOS FCOE support. So what it is in the FOS. One of the target markets for this was to try to take back some of the Cisco stuff and let the UCS chassis come into the B series fabric. So here's an example of a supported topology. So they have a Cisco UCS rack server, blade server going through their fabric interconnect. And from there, it can come into the chassis. It can come into a pair of blades, one blade, whatever you want. This can be a port channel to 2 different blades, which is a good idea for HA purposes. And then over here on the right, we've got a regular fiber channel port going to a fiber channel storage array, so like a 3-par. So you could have a fiber channel 3-par and have a Cisco UCS doing FCOE and talking to it. Okay, another supported topology would be the same, Cisco UCS into the Fabric interconnect. And in this case, they've taken this is one of our 4-slot directors, and someone has created a logical switch with the top half and a different logical switch with the bottom half. So in this case, 2 port channels have been created, one port channel to the bottom half and 1 port channel to the top half, and then your storage has connections to the top and the bottom. And so then your basically the top half of the Cisco UCS can go through this top port channel through the blue fabric to the storage array, and then the bottom half can go through the orange fabric to the storage array. So that kind of flexibility is allowed as well. This is an unsupported topology. So notice we have lost, in this case, the Cisco Fabric interconnect is not in this picture. We do not support this connection, and I think I have some slides about why. If I don't have them in here, they would be in the product update training. So you could go take that and see more details about this, but this isn't supported. So the Cisco UCS interrupt traffic test matrix. So what we've tested is the Cisco UCS server at 10 gig or 40 gig, and then the Fabric interconnect in the full matrix of all 4 permutations, and then connecting to our blade, and it's going to have to the speeds between the Fabric interconnect and the 8600, of course, have to match, so either 10 gig or 40 gig, and then the FC targets can be 816 or 32, whatever. At that point, that matters not very much at all. It'll just run at whatever speed is the fastest that either the server or the target can run at. But we do support, the main thing here is we support those 4 permutations. So the reason why we require that Fabric interconnect is because the UCS server doesn't send out the FIP frame, but the Fabric interconnect does. And so we need that frame to be able to bring up all the FCOE components. So there's a few different things in here, but the basic thing is the workaround is to provision the port on the blade in UCS mode, so that because we've worked through all these different caveats, and so we know if you put it in UCS mode, it expects these funny things, and then everything will work fine. And then there's a couple more known issues with the Cisco UCS FCOE. Okay, so that's it for FCOE for now. I'm going to move on to BNA 14.4 enhancements, and this is going to be this deck. This module 6 in the product update training is much larger in the product update training. I've taken up a lot of the slides simply because of time, but I'm going to go through this. I'm going to run through here, give you a taste of the updates in BNA 14.4, and we'll talk a little bit more about FCOE since the FCOE support is in here as well.
So this new version of BNA will recognize the SN6650B switch as well as the SN8600B switch, the 232 gig units that we've been talking about that are new for this release. If you have an older version of BNA, it won't understand what these are, so it'll show up as an unknown, just like it has always. That's not really anything new. This is just where the support for these 2 new platforms show up.
For FCOE support, we do support discovery and configuration of the FCOE. There is limited FCOE support with Gen 6 and 8.2.0. You can use web tools instead for your FCOE primary configuration. So there's not fully fleshed out in here. It was a lot of work to get it in there, and then of course BNA always lags behind. Is kind of how it all works. So, but it does show up, and you can see it in here to see what's going on. We do support Ethernet port performance support, so you can see transmit and receive frame rates and things in here. So and it does show up in the top port utilization and top port traffic widgets. So it does show up in here to be displayed like you would expect. Also in 14.4, we support NVMe support and discovery. I've talked about that a little bit, but that is in BNA as well. So if someone was to have an NVMe capable host and an NVMe capable storage array, BNA will understand that it's NVMe and give you statistics and understand what's going on. Here's an example of an NVMe device that was discovered and it's in the tree. The picture's a little small, but it does show up. You can see it, and it does over here, number 3. It does say FC NVMe in there. It's a little hard to read in there. It does understand what's going on. Of course, the way for Brocade, mixing standard fiber channel or FCP and NVMe in the fabric doesn't really matter to us at all. Mix it up as much as you want. Of course, the only caveat is if you to talk to an NVMe storage, you have to have the NVMe driver on the host, and as long as you've got that, you can run it. And we don't care if you mix things up, or if your host is talking fiber channel and NVMe at the same time. It doesn't really matter to us. But we will display what's going on. So in this case, down here in number 3, it does say FCP and FC NVMe, so it does know that device is doing both at the same time, which is perfectly fine for us. In Network Advisor, the NVMe devices are going to be displayed with the help of the namespace identifier attribute, and the flow monitor supports it, and we only support monitor and mirror flows with the Gen 6 platforms, but with the custom widgets, top end flows, bottom end flows displays the NSID values, so that does show up in there. If you want to define a flow, then you have to use the NSID to specify. NSID can be specified only for the Condor 4 Plus port, because that's the one that has the extra smarts in there to understand what's going on with NVMe. The NSID can't be specified with the VM entity ID, and it can't be added along with the LUN. And NVMe does not support frame type at this point, so that's something that will come along at some point later in the future. NVMe supports 2 new measures for byte performance, so read IO byte count and write IO byte count. These can only be measured if the selected ingress or egress port is a Condor 4 Plus port. The frames can flow through the Condor 4 with just fine, but the ASIC can't give us the counts, which is that's why we built up the Condor 4 Plus. And of course, the data size ranges are the standard values that we've been using for a long time. So if you're going to do some graphing, in here you get frame, SCSI, IO latency performance, and byte performance in here, so you can do graphing like you would normally for real-time and historical graphs with NVMe. Switching gears a little bit, now we're talking about fiber channel and IP extension. So Network Advisor 14.4 does support parallel FC IPEX hot code load on a Gen 6. So both ends, it's initiated on both ends of the extension link on the Gen 6 chassis with the SX6 extension blade. So in previous releases, if you tried to do the parallel download, the firmware download on all the HCL supported devices would be initiated in a serial manner to avoid traffic disruption. But in 14.4, if you want to do a parallel download with Gen 6 switches, the download should be initiated in parallel and completed successfully without traffic disruption. So they've added true parallel hot code load with the Gen 6 chassis. The older Gen 5 chassis, the SN8000 and SM4000B, will still enforce the serial download just so that you don't have any traffic disruption, which is a good thing. Here's an example. This box here up top, it says serial download. So if that box is unchecked, it's going to do a parallel download, and if both ends are Gen 6, it will actually do a parallel download. But it's smart enough at least to, even if it's unchecked, if it needs to be serial, it'll do it serially. So another new feature that actually you guys are some of the ones that care more about this than some of the other folks, but target-driven peer zones, which is something that your 3PAR uses, we've added in support for aliases. So instead of having to specify only the worldwide name, now you're able to use the aliases in the target-driven peer zones. And so the 3PAR folks are working on this to add that in to support on their end now that the feature's available on our end. But using aliases instead of having to use all the worldwide names makes your life a lot easier, of course. And it makes it much more readable when you're looking at things, so you get the alias ripples through everything and you know what it is without having to look up the worldwide name all the time. So this is just an example of target-driven alias supporting the target-driven peer zones and doing the zone merge comparison, so you can see what's changed, what's different. So another example of this, what the screens look like. If you view the zone aliases present in a target-driven zone under the activation dialog, so you can see them. You can see like that guy's in there, and then this guy's down here too. You can see them if you just export it as an XML file too. You can if hiding the peer zone property member, the property member is a read-only member used to depict what kind of members are present. Because it's hidden in CLI commands like zone show and CFG show from 8.2 and onward, the property member is hidden in the GUI as well, because it's not something you really normally want to see, and it's just makes it a little more confusing for the end user. And it's also hidden if you do the compare merge and importing into the zone database. And if you do the export, it's visible in the XML file, so it's happening in the background, but it just isn't showing it to you because it's just extra stuff that, unless you really know what you're looking at, it doesn't really make much sense. There's also zoning support for FCOE devices in BNA 14.4. So the old style domain index ports, the port zoning is not supported for FCOE devices. It needs to be worldwide name based zoning. So you can see worldwide name for FCOE here. The domain index is not supported with FCOE, so it needs to be with the worldwide name. And here's another example of the GUI and what you would see. So you can see here that, switch 100, it shows ETH port. So you can see that that's an Ethernet port there. And then up here you can see Ethernet zone, and it's got a device and a worldwide name in there. Some infrastructure changes to BNA I'm going to go through now. So some of the installer changes. So the install anywhere upgrade is updated from 2015 to 2017. The GRE has gotten updated. The OS that the Network Advisor 14.4 can run on. So Windows Server 2016 R2, 2008 R2, 2012 R2, 10 Enterprise. So that's the list of where you can install this and run it.
Now let's talk about some of the web tools enhancements that are included in this FOS release.
So of course, with web tools, there's new platform support to support the SN6650B or the G630 as we call it. So this is what it's going to look like in the web tools GUI. So it looks pretty similar to what it looks like physically. So it should be pretty obvious what you're looking at here. All 96 SFP ports, and then the 32 QSFP, or the 8 QSFP ports with 32 ports total. And it actually breaks out each port. So you can see the top QSFP and the bottom QSFP there as 4 ports. Platform support for the blade in the SN8600B chassis. So here at the bottom, you can see it's got lots of ports because it does try to break out the ports so you can see what's going on. And it has the LEDs and everything in there, but it does show up in your web tools for that blade as well. Let's see. So in the web tools support for the 32 gig blade, it does display the CE interfaces, the FCOE ports, and properties and statistics. Displays your FlexPort configuration, and it also displays your CE interface configuration. So the lags, fabric map, enode configuration, and LLDP configuration. So all that stuff gets displayed in the web tools. If you're going to do some port admin in the web tools, so this is kind of where you would find it. So if you've selected your slot and you've got some actions, and then it does show FlexPort, and you can have Ethernet or Fiber Channel to apply to your blade. So that is configurable via web tools. You also have CE interfaces and FCOE ports and LLDP neighbors tabs that's on here now. So those, of course, only appear if you have this blade inserted in the SN8600B. Without that blade, you don't get the tabs because they don't apply. The CE interface tab displays allows you to edit the interface configuration, so you can see the interface, the MAC, and what state it's in, and also the speed over here in the bottom right. Okay, so you also have an FCOE statistics that you can see in here. So in this case, we've got the slot, and this port on the slot is selected, so it's slot 8 port 60 on the 64 port blade. And under FCOE statistics, you can see, FIP VLAN discovery responses, all the different kind of stuff that you'd expect to see on an FCOE port. Of course, it's transmitted and received. There's also a connected devices tab that shows up under the CE interfaces group. So you can see in here that what's connected. So the Ethernet port's this, and then what's connected on the other side. So you can kind of just find out, map through what's going where. And then the FCOE ports tab shows all the virtual FCOE ports available, and it can be viewed on any FCOE capable switch, even if it doesn't have any flex ports, simply because it knows that it's capable. And then from here, you can enable or disable the FCOE ports. So it shows the port index, the port type, the world by name, and then the status and the state. In this case, these are all enabled, but they're all offline right now. Okay, so that's it for the web tools. Yeah, the BNA and the web tool stuff went pretty quick. I haven't been really any questions, so that went fairly rapidly, a little more quickly than I expected. But the key points from this morning, I believe we're basically wrapping up now. The SN8600B 64 port, 32 gig, 64 port blade. It's got the Condor 4 Plus ASIC on it. It supports both FC NVMe and flex ports, FC or FCOE to hosts without any additional licensing. As Matt mentioned, it's going to ship with 8 of the 32 gig QSFPs pre-installed, so it'll be half populated, and if the customer wants more, they can buy some more QSFPs and pop them in. The SN6650B, which is the 32 gig, 128 port fiber channel switch, it also is based on the Condor 4 Gen 6 ASIC. You've got 96 32 gig SFP ports, and you've got 8 128 gig QSFP ports. You got with 4 terabits of bandwidth, and they packed that sucker into a 2U form factor. It does support pods, both for the SFP and QSFP ports separately, so you can decide which ones you want to use when. It also allows you to integrate NVMe ready solutions. So if you have both of these, you can run NVMe through the 6650 and get all the stats as well. Some of the FOS 8.2 and Network Advisor enhancements are FCOE server connectivity via flex ports, dport and blade fault auto recovery, some of the things that we've talked about. So that wraps it up for today. Does anybody have any questions they want to ask? If we can bring people off mute if they'd like.
Yeah, so there were a couple
Sure,
in the questions too that I was just going to cover while you take everyone off mute. So back on the blade auto recovery, someone had asked what kind of failures can it recover from, and specifically, can they recover from I2C bus issues? Now, I know I've been looking during the session here to find any more information, and the best I found was on slide 47. You have a fault code and reasons there. I don't see anything else in the documentation besides that.
Let me go back and look. I don't want to answer. I think it does include I2C, but I'd have to go back and double check that before I gave you a solid answer. So I'll find out. I'll let you know, Matt.
Okay. And then someone had asked about the serial cable. Does the switch need a special serial cable? And I had commented that it's the same serial cable we've been using with the Gen 5 and Gen 6 switches.
Yeah, absolutely. Okay, any other questions or anything else pending, or anybody have anything?
I can open the line for the verbal questions. Should I do that?
Okay. Yeah, please.
The participants have given you access to the microphone. You just need to click the microphone to unmute. Microphone is just before the speaker icon, top right. Also, please note that the handouts are available. The second icon from top left will help you to save the handouts. You need to right click on it and click on export. Well, we're looking for any questions that you may have now. All right, I see one hands up.
Okay, yes, Stefan here. My question is regarding the breakout on the ISLs. It is a must breakout the QSFP that you connect 2 of the ISLs to the bottom and 2 of them to the top?
When you could do that. You could mix it up, but you're still going to want to connect to the other. If you're using a top QSFP, you're going to want to also connect to the bottom QSFP to spread that load in the internals.
Okay, so it's a load issue, but not a configuration. I could connect all 4 of them to the top one.
You could, yes. It's not going to be so. You can connect. Do you mean all 4 ports within a QSFP or all 4 QSFPs?
No,
Yes.
all 4 ports inside the QSFP.
Yeah, so generally the best practice would be to take all 4 ports in the QSFP if you need to break them out to a switch that doesn't have QSFPs, and just take all 4 of those and from that QSFP and connect it to the switch, and then take all 4 from a bottom QSFP and connect it to the switch as well. So you end up with 8 connections. Now you could, if you didn't want to use all of them, you could say take 2 off the top QSFP and 2 off the bottom QSFP and connect it to another switch too. Yeah, that would still work, but because you've still followed the top-bottom balancing best practice. You just don't have a ton of bandwidth, but it still would work, yeah, if that's what you're trying to ask.
Okay, thanks.
Mm-hmm. Thank you, everybody, very much. I'll get back to Matt on the blade fault auto recovery question. But yeah, thank you very much for your time, and have a great rest of your day.
Thanks, Troy.